So let's look at rational numbers first. So rational numbers is a set of numbers where if you can write the number as a over b, okay, if you can write the number in the form of a fraction as a over b, where a and b are integers and b is not equals to 0, then it is called a rational number. Any number that can be written in the form of a over b is known as a rational number. If it cannot be written in this form, then it is an irrational number. Okay, so both a and b are integers and b is not equals to 0. Okay, if both a and b are positive, and if a is if a is less than b, then it is called a proper fraction. So examples of proper fraction: 1 over 2, 1 over 5, 2 over 8, 6 over 7. These are all examples of proper fraction. If the numerator, okay, the number on the top, we call it the numerator, and the number at the bottom is the denominator. Okay. Okay. If the numerator is smaller than the denominator, then this fraction is known as a proper fraction. If a is greater than b, that means if the numerator is greater than the denominator, then the fraction is known as an improper fraction. Okay. Examples: 4 over 3 or 5 over 2, 16 over 12. All these are improper fractions. Okay. A whole number is when b divides evenly into a, then you call this a whole number. What about this number? What do we call this number? Is this a proper fraction or an improper fraction? 7 over 7. Anyone?
Whole number.
It is a whole number. If you divide 7 over 7, you get 1, okay? So 1 is a whole number. But when you write it in the form of a fraction, it is a fraction. But is it proper or improper?
Proper.
Improper, huh? Improper fractions are when they're greater, and also when you write it like this, it's equal. It's also known as an improper fraction. Of course, when you divide it, then it's a whole number, okay? So we go by the definition that any number that can be written as a fraction is a rational number. Okay, let's look at this table here on my right here. 5. Is 5 a rational number or not? Rational number? You think it's a rational number?
Yes.
Okay. Why do you say it's a rational number?
Integer.
Okay, it's integer. What else? What other reason? You must check this. This is our definition, A over B. So ask yourself, can you write 5 in the form of a fraction? Can you write 5 in the form of a fraction? How do we write 5 in the form of a fraction?
5 over 1.
Yes, 5 over 1. This is a fraction. So because you can write it in the form of a fraction, therefore it is a rational number. So we go by the definition. If you can write it in the form of the fraction, it is a rational number. If you cannot write it in the form of fraction, then it's not a rational number. So 1 over 8, we know that it's already in the form of a fraction. Therefore, it is a rational number. How about 1.75? Is this can you write this in the form of a fraction? Is it possible?
7 over 4.
Yes, first step, 175 over 100. And this is 7 over 4. Okay, so 1.75, you can write it as a fraction because it is equal to 175 over 100. Because you can write it in the form of a fraction, it is a rational number. How about this, 0.001? Can you write it in the form of a fraction?
1
Yes.
1 over 100.
1 2, 3. 3 zeros. So 1 over 1000. Therefore, it is a rational number. Negative 0.1. Write it in the form of a fraction.
Negative 1 over 10.
Yes. Is this a rational number? Not sure?
Not sure.
Okay. So now you know. It is a rational number. How about square root of 4? Can we write this as a fraction?
2 over 1.
Yeah, 2 over 1. We know the square root 4 is 2. So this is 2 over 1. So this is a rational number. How about square root 2? So this one is 1 point something, something, something. So we cannot write this because if it's like 1.1, you can write this in the form of fraction. But this one, it doesn't end. So we cannot write it in the form of a fraction. Okay. So we can't write it in the form of fraction. Therefore, this is not a rational number. So if you want to identify if a number is rational or not, what do you do? How do you identify if a given number is rational or not?
Do fraction.
Yeah, you see if the number can be written as a fraction, as A over B. Okay. If it can be written as a fraction, it is rational. If it cannot be written as a fraction, then it's irrational. Okay. 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 So from this table here, we can make several conclusions. Okay. We can say from here we know there are whole numbers. And so on. Okay, so from this table we can say that all integers, okay, all integers are rational numbers. Okay, and we can also say that all whole numbers, okay, all whole numbers are rational numbers. And we can also say that all natural numbers, all natural numbers are rational numbers. Okay, if we represent integers with the letter Z, whole numbers with the Z letter W, natural numbers with the letter N, and rational numbers with the letter Q. Okay, so we can draw a Venn diagram to show the relationship between these numbers. Okay, if my Venn diagram is like this, okay, so this is my Venn diagram. So outside here is R. What is R? What does R represent?
Rational number.
Q. Q represents rational number. So R will be, this is fixed. We don't change this. This one is already fixed, all this. Okay. Z always represents integers. W is a whole number. Okay. It's a symbol for whole numbers. N is a symbol for natural numbers. R stands for
Real number.
yeah, real numbers. R is real. All numbers come under R, real numbers. So what do you think is the smallest set here? What does it represent? Okay, let me tell you. The outside here is Q, rational numbers. This set is, next to it will be, is it whole numbers or is it integers? Which one is a subset of which? Is whole numbers a subset of integers or is integers a subset of whole numbers? How? Whole numbers, it starts from what? Whole numbers.
Whole number subset of the integers.
Whole numbers is a subset of integers. Okay. Whole numbers starts from what number?
0.
0, okay? 0 onwards, correct. So whole integers, they have positive numbers and negative numbers. Huh? So we know
yes.
if you draw a number line, this is 0, 1, 2, and so on. This is negative 1, negative 2. These are all integers. This side is all whole numbers, correct? From 1 onwards, it's natural numbers. So this inside set is for natural numbers. The next to it is whole numbers, and outside there is Z, which means that N is a subset of W. Okay, that means N is inside W because N starts from 1, 2, 3 and all that, whole natural numbers. Whole numbers is bigger, so N is a subset of whole numbers. Whole numbers starts from 0. Whole numbers is a subset of integers because integers is from negative and positive. Whole numbers is only the positive numbers. So whole numbers is a subset of integers. And integers is a subset of rational numbers. Okay? Integers is a subset of rational numbers. So later you will learn that there is another set of numbers, and this is called Q prime is irrational numbers. Okay? So that means from this diagram we know that all real numbers consist of rational and irrational numbers. Okay? So that means all numbers can be categorized into two, rational and irrational. So whole numbers consist of rational and irrational numbers. Under rational numbers, we have integers, whole numbers, natural numbers. They are all part of rational numbers. Anything that's not part of rational numbers is irrational number. Okay? Okay?
Okay, madam.
Okay. So we finished with the introduction to rational numbers. So we're going to look at the next thing is okay. We're going to see how we can use HCF to reduce fractions. We know that all fractions are rational numbers. So part of using rational numbers and knowing and using rational numbers is knowing how to use HCF to reduce fractions. As you know, you have already studied HCF, right? HCF stands for
Highest common factor.
Yes,
correct. Highest common factor. So now we are going to use this concept to reduce fractions. In fact, we've already learned this also. Okay. If we have a number like this, A over B, and the highest common factor for this number for A over B is 1, that means this fraction is in the simplest form already. Okay, it's in the, you call it simplest form, or you say reduced form. Okay, reduced form or simplest form, or you can even say lowest term. All these mean the same thing. Okay, so if the highest common factor for A over B is 1, for A and B is 1, then it is already in the reduced form. So every time we answer questions that have fractions, our answers in fraction, we must make sure that it is in the lowest term or in the reduced form. Okay, so now we're going to see how we can use HCF to reduce fractions. Let's do one example. We want to reduce 24 over 30 to its lowest form. So I think we've already done this before. What do we do now? What do we need? We need to find the highest common factor for 24 and 30. How do we do that? First step is to
Prime.
okay, find
Prime
Divisibility.
yes, find the prime factors. Yes, find the prime factors. So prime factors for 24, 6 times 4, or can be 12 times 2. 6 is 2 and 3. 4 is 2 and 2. This is the 3 factor, remember? So 24 is equals to 2 times 2 times 2 times 3. Actually, we should write 2 to the power of 3 times 3. But this time I'm not going to write because I'm going to find the HCF directly from here, okay? And then 30, break it up into its prime factors. We have 5 times 6. 5 is already 5. 6 is 2 and 3. Therefore, 30 is equals to 2 times 3 times 5. Now, what are the same factors here? We have 2 here and 2 here. 3 here and 3 here. Therefore, our HCF is 2 times 3, which is 6. So we know that our HCF is 6. So now we want to reduce 24 over 30. So 24 divided by 6, divided by HCF. 30 divided by 6 gives us 24 divided by 6, 4. 30 divided by 6, 5. So now we have reduced the fraction. This is the lowest term. For this term, you cannot divide it anymore. HCF is 1 already. So now it is in the reduced term. Okay, so this is how we use HCF to reduce the fractions. Okay, now let's look at another example. Okay, reduce 300 over 144. So what we're going to do first, we're going to find the prime factors for 300. So 300 is equal to, how can we break this up? 300 is, let's go with 100 times 3, 300. 100 is 10 times 10. 10 is 2, 5, 2, 5, 3. So 300 is 2 multiplied by 2 multiplied by 3 multiplied by 5 multiplied by 5. So 144, break it up into its prime factors. 12 times 12. Actually, you shouldn't forget this. We've done a lot of this, okay? So this is 6 times 2, 6 times 2, 2, 3, 2, 2, 3, 2. So 144 is 2 multiplied by 2 multiplied by 2 by 2 by 3 by 3. Yeah? 1, 2, 3, 4 and 2. 4 and 2. Okay. 1, 2. Okay. So now, sorry. Okay. So now let's look at the similar factors. So we have 1, 2, 2's here. 1, 2, 3 and 3. 5, we don't have 5 here. Okay, so we're only looking at the common factors. So HCF is equals to 2 multiplied by 2 multiplied by 3. What we did earlier was we drew the Venn diagram, remember we drew the Venn diagram, we put in the values inside here, 2, 2 and 3, and this is our HCF. Same thing I'm doing here, okay? 2 times 2, 4, 4 times 3 is 12, so HCF is 12. Now we want to reduce 300 over 144 using HCF. So divide by 12, 144 divide by 12. So what do we get? We get 25 over 12. This is an improper fraction. We can still reduce improper fractions. So this is an improper fraction already. It is already in the reduced state, really. Reduced form. We cannot reduce anymore. But we can simplify it by saying this will be our next answer, 2 over 12. Okay. But this one here is in the reduced form. Okay. So this is how we reduce fractions using HCF. Okay, any questions?
No.
Can, okay, so we continue. So we have seen that how we can reduce rational numbers of fractions. So next we're going to look at complex fractions. Okay, complex fraction. A complex fraction is a rational expression that has a fraction in its numerator, denominator, or both. In other words, there is at least one small fraction within the overall fraction. Okay, a fraction in a fraction. That is what we mean by complex fraction. Okay, I'll give you an example here. Examples of complex fraction. Okay. 3 over half. The numerator is a whole number, denominator is a fraction, but there is a fraction in the denominator here, okay? Example 2, 3 over 7 over 9, a fraction in the numerator, a fraction in a fraction, okay? Example 3, 3 over 4 over 9 over 10. Here we have a fraction in the numerator and in the denominator, okay? All these examples are all known as complex fractions because there is one fraction inside another fraction. So it's already fractions are complex. We have now it's even worse when we have one fraction inside another. Okay, so let's see how we can solve some problems involving complex fractions. Okay, say you want to simplify this. Okay, you want to simplify this. 9 over 4 divided by 11 over 12. To simplify this, you write down the numerator. Okay, we know that this is the numerator and this is the denominator. Okay, so we just write down the numerator and we multiply it with the reciprocal of the denominator. Okay, if 11 over 12 is the denominator, okay, then the reciprocal of the denominator, okay, is 1 over 11 over 12, which is actually 12 over 11. Okay, if you have a number 5 over 6, what is the reciprocal of 5 over 6? Salingan. What is the reciprocal of 5 over 6? Reciprocal means 1 over 5 over 6. It's actually 6 over 5. If you have a number A, what is the reciprocal of A? 1 over A. If you have a number 7 over 8, reciprocal is
1 over 7.
8 over 7. Okay, like that. So to simplify these fractions, we write the numerator and we multiply by the reciprocal of 11 over 12, which is 12 over 11. Now we can simplify 1, 3, this is 27 over 11. Okay? Okay, let's do one more example. Okay, given that x over 10 divided by 4 over x is 8 over 5, calculate x. You want to calculate x. So this is a fraction in a fraction. It's a complex fraction. I'm sure we already know how to do this. We have studied all this in school, okay? But maybe you didn't know that it's called a complex fraction. So this is how we always do it, okay? So x over 10 multiplied by, we always just reverse it, right? So it's the same thing. It's the reciprocal of this. 4 over x is x over 4 is equals to 8 over 5. So x times x is x squared over 40 is equals to 8 over 5. So what do we do with the 40? We want to take it over the other side, or to eliminate 40, we multiply by 40 equals to 8 over 5 multiplied by 40, okay? You have 8 here. So x squared is equals to 64. X is equals to plus minus 8. Okay. Okay, so we have that. So this is operations or calculations using involving a complex fraction. Okay, I want to do one last one example. We have reduce this. We want to reduce this. Okay, 2x cubed over 3y divided by x squared over 6y. We want to reduce this or simplify this. In other words, this means just write the numerator down, 2x cubed over 3y multiplied by this one, multiplied by the reciprocal of the denominator. So we multiply by 6y over x squared. Okay, so how do we do this? We cancel x square here, remainder x. Okay, 3 and 2, y and y cancels off. So we have 4x. Okay, that's our answer. Okay, these are called complex fractions and operations with complex fractions. Okay, can be done?
Yes.
Yeah, this is normal thing. We normally do this. You have seen this before already. Okay. Okay. Next, we're going on to continued fractions. Okay. Okay. This one you have to listen carefully. Okay. This one's a little bit difficult. Okay. Continued fractions. Okay. Let's see how to do it. One question first. Okay. Find the continued fraction representation of 415 over 93. Okay, how do we find the continued fraction representation of 415 over 93? Okay, so we know that 415 over 93 is also equivalent to, if we divide 415 over 93, 415 if we divide by 93, what do we get? We get 4. This gives us 372. What is the remainder here?
43.
43, yes. So we know that 415 over 93 can also be written as 4 plus 43 over 93, correct? And this one is actually 4.4624. This is the actual value of this. Okay, this is the actual value. First line, okay? Everybody agree with this? Yes?
Yes.
Okay. Okay. So 43 over 93 is the reciprocal of what? It's actually the reciprocal of anybody? (43 over 93 is salingan for what number?
(93 over
93 over 43, right?
Yes.
Correct. 43 over 93, I'm telling you already, is the reciprocal of what number? 93 over 43. Why? 1 over 93 over 43 is 43 over 90. 43 over 93. Okay, so 43 over 93 is the reciprocal of 93 over 43, and 43 over 93 is actually 2.1628. If sorry 93 over 43 is actually 2.1628, which means that 93 over 43 is approximately equal to 2, right? 93 over 43 is 2.1628. So 93 over 43 is approximately equal to 2. Lebih kurang sama dengan 2, yes? Very near to 2. Correct or not? Yes?
Yes.
Yes.
Okay, so because of that, 415 over 93 is also equals to 4 plus 1 over 2. Can you understand that? Why that? Why is like that? Because 43 over 93 is the reciprocal of this, correct? It's 1 over this. 43 over 93 is 1 over this. And you know that this is 2. So that means 43 from here, we can deduce that 43 over 93, I tell you, it's 1 over 93 over 43, right? So 93 over 43 is approximately equals to 2. Therefore, 43 over 93 is 1 over 2. Is approximately equal to 1 over 2, correct? So this number is equals to 1 over 2. Correct?
Yes.
I told you it's a bit difficult. Okay, so we've reached until here already, okay? 1 over 2, okay? So we're going to continue. But we also know that 93 over 43 is equals to 2 plus the balance is 7 over 43. When we divide 93 with 43, we get 2. Balance is 7 over 43, okay? Correct? But 7 over 43 is the reciprocal for?
43 over 7.
Yes. It's the reciprocal of 43 over 7. And we know that 43 over 7 is equals to 6.1429, which is approximately equal to 6. Therefore,
1 over 6.
7 over 43 is 1 over
6.
1 over 6, huh? Yes, 7 over 43 is 1 over 6. So therefore, this is 4 plus 1 over 2 plus 1 over 6. Do you understand or not? Why?
Yes.
A little bit complicated.
Okay, a little bit complicated, yes. Because 93 over 43 is 2 plus 1 over 43 over 7, correct? So this is 2 plus 1 over 6, right? This is equal, this is almost equals to 6. This is 2 plus 1 over 6. So 93 over 40. So 43 over 93 is 1 over the whole thing. Okay, so that means 43 over 93 is 1 over 2 plus 1 over 6. So that's why we have 43 over 93 now is 1 over 2 plus 1 over 6. Okay? Okay, last step. Huh? Oh, so I have to go a bit smaller here. Okay, so last step is we have so after this we have 43 over 7 is equals to 6 plus 1 over 7. Okay, and we know that 1 over 7 is reciprocal of 7. Okay, and 7 is equals to 7 plus 0 over 1. Okay, 7 over 1 is 7 plus 0 over 1. So when we reach 0 here, we can stop. So we know that 43 over 7 is 6 plus 1 over 7. Okay, so what do we do now? So V143 over 93, right? So it is, so that means this one will be 4 plus 1 over 2 plus 1 over 6 plus 1 over 7. Okay? No sound is it good or bad? Okay, class, can I understand or not? A bit difficult, huh? Okay, I will show you
Yes.
another way that you can do it a bit easily. But this is just for you to understand, okay? So 415 over 93 can be written in continued fraction like this, okay? Or it can also be written like this. The same thing, this answer, we can write it like this. Okay, the first integer here is 4. Okay, so we write 4 semicolon. Next integer is 2 and then 6. So we write here 2, 6. Okay, this is the other way of writing this. Okay, okay, let me do one more example. Okay. Show you a different method. That's just for you to understand why we're doing that. Okay, represent 137 over 33 as continued fraction. Okay, so we start with the first fraction. 137 over 33 is what plus what? What is the remainder? And 137 over 33 is 4 plus remainder is 137 divided by 33 is 4. 33 times 4 is? Right. Okay, what is the remainder? Is 5, right? So this is 4 plus 5 over 33. Now we take the reciprocal of 5 over 33. So it becomes 33 over 5. So 33 over 5 is 33. When we divide by 5, we get 6 plus remainder is 3 over 5. Now take the reciprocal for 3 over 5. We get 5 over 3. 5 over 3 is 1 plus remainder is 2 over 3. Take the reciprocal of 2 over 3, you get 3
3
over.
over 2.
This is 1 plus 1 over 2. How do we get this? Just do long division. So we get this. So 1 over 2 becomes 2
2
over 1.
over 1.
2
2
plus 0 over 1. When you reach 0, you stop. Okay, so from here we can write down our answer. Okay, 137 over 33 is equals to 4 plus 5 over 33. Okay, but 4 plus 5 over 33 is also equivalent to, what is 5 over 33? 5 over 33 is 1 over this, right? 5 over 33 is 1 over 33 over 5. Same, right? These two? This equals to 5 over 33. Correct? Do you agree with me?
Yes.
So 5 over 33 is equals to 1 over 33 over 5. What is 33 over 5? Is this whole thing. So it is 1 over this. So this is 4 plus 1 over 6 plus 3 over 5. Okay? And this is equals to 4 plus 1 over the next one. Okay? 6 plus 1 over 1 plus 2 over 3. And this is equals to 4 plus 1 over 6 plus 1 over 1 plus
2 over 3.
wait, yeah, so this is 6 plus 1 plus 1 over 1 plus 1 over 2, the last one here. 1 plus 1 over 2. Or we can write this as 137 over 33 is equal to first integer is 4. Semicolon. And then we have 6, 1, 1. 6, 1, 1. Okay? This. Or these two different ways of writing it. So this is continued fraction. Can you understand that?
Yes, madam.
Everybody can?
Can, madam. Okay.
Okay. Let's do one more. Represent 11 over 7 as continued fraction. Okay? 11 over 7 is equals to, you give me the answers, is equals to what plus what?
1 plus 4 over 7.
Okay, good. 1 plus 4 over 7. Step 1. Step 2.
Reciprocal the 4 over 7.
So what's it?
7 over 4.
7 over
Yes,
4.
7 over 4 is equals to,
1 plus 3 over 4.
okay, next step.
4 over 3.
4 over 3 equals to,
1 plus 1 over 3.
next step, correct? Next step.
3 over 1.
3 over 1 equals to,
3 plus 0 over 1.
okay, so once we reach 0, we can stop.
Stop.
So our answer is 11 over 7 is equals to, we
1
start with the
plus
first, yes, 4 over 7, this is equals to 1 plus
1 over
1 over 1,
1 plus 3 over 4.
correct, equals to 1 plus 1 over
1
1 plus 1 over, next line,
1 over 3.
1
1
plus
over
1 over 3,
1.
the whole thing, 1 plus 1 over 3, okay? So that's finished, we stopped here already, okay? Or 11 over 7 is equals to, the first integer is 1 semicolon, the next two integers are 1 and 1, so it's 1, 1, okay? Can
Okay.
understand?
Okay, kot madam.
Okay, so the important